Assalamualaikum and hello. In this video, I'm going to introduce to you how to identify the substituents or alkyl groups that can exist in a structure. We are going to give the names for alkanes based on some rules that you have to obey. Let's go to the first rule where you have a straight chain alkane with no substituents attached to it. So how you want to give the name for alkane? It depends on the prefix and suffix. Suffix is the parent name. For example, in this case, alkanes, at the end of the naming should be A and E, N, as your family name. And the next one in front of it will be prefix, which is going to be the number of carbon atoms in the chain. If I got one carbon atom, the structure will be CH4 and the name will be methane. The next one, if I got two carbon atoms, my structure is going to be CH3CH3 and the name will be ethane. And once the number of carbon atoms are increasing, the name will be changed. But as you see from here, each of them got the suffix name, the family name, ended with "-ane", A and E. So that's how you want to give the name for alkane with no substituents, and it is in a straight chain alkane. Next one, we are going to focus for the second part where how you want to give the name for alkanes where you got the substituents attached to it. So first thing first, determine the longest carbon chain, which is your main chain. So this is going to be the longest carbon chain that you have in the example given. And the next one, you have to take a look at the family name. In this case, the family name will end it with A and E because it is an alkane. And the substituents is depending on the structures given. And the substituents can be alkyl groups or a group of atoms. This is where I'm going to introduce to you a lot of substituents that can be found in any structures when you do the exercise. The most important things for you to understand is the symbol capital P that I wrote here is referring to a parent chain. So it means that you have to determine the longest carbon chain for your structure. For example, if I got one carbon atom attached to my parent chain, it will be less one hydrogen and the structure will be CH3 and the name will be changed to methyl. So methyl is one of the alkyl groups that can be added as substituent. Next one, if I got two carbon atoms which is attached to parent chain, the structure will be CH2CH3 and the name will be ethyl. Make sure the carbon that attached to the parent chain is CH2 and then after that continue with CH3. Next one, I got three carbon atoms. There will be two types of substituents that can exist with three number of carbon atoms. The first one is propyl and the second one is isopropyl. The structure for isopropyl is just like when you draw kaki ayam. So this is how you draw kaki ayam. For example, if I draw in the skeletal structure, I got my parent chain attached to one carbon and then two carbon and then the third carbon. So this is the structure for isopropyl in skeletal structure. Next one, we go to four number of carbon atoms. So if I got in the straight chain with four carbon, the name for alkyl group will be butyl. And the next one, if I got four carbon atoms as well, but right now the position will be changed just like this structure. So the name will be isobutyl. Iso means that you have to show in form of kaki ayam. It means that dia akan mencapah. Seperti mana yang saya draw this one, I got kaki ayam 1, 2 and 3 carbon. Right now we got 4. So before you attach to the parent chain, you got one carbon atom, and then you got attached to parent chain. So this is how you want to draw the isobutyl in form of skeletal. I hope you are clear with the difference between the straight chain and iso structure. As you see here, isopropyl you got kaki ayam like that, and isobutyl as well you got kaki ayam like that. But the difference is the number of carbon atom. Here you got 3 carbon atoms attached directly to the parent, but right now you got isobutyl with 3 here, but you got 1 more left. So make sure you attach to the last carbon atom before directly attach to the parent chain. Next one, we got sat-butyl. Make sure you got the naming with dash, sat-butyl. So sat means that secondary carbon. Which carbon it is referring to? It is referring to this carbon that attach directly to the parent chain. So how you want to draw this one? Make sure you draw this carbon that attach directly to the parent chain as secondary class of carbon. So if you draw it in skeletal structure, you can draw it P, parent chain attached to my carbon, and you got 2 here, and then you got 1 here. So this carbon will be the secondary class of carbon. Now we go for the last substituent with 4 carbon atoms, which is third butyl. Make sure you put the dash here, third dash butyl. So this is the structure for third butyl, where you got 4 carbon atoms, but in the middle of it, this carbon that directly attached to the parent chain is tertiary carbon. Now we go to 5 number of carbon atoms. If it's in the straight chain, it will be pentyl. And then if it's in isopentyl, make sure you draw the kaki ayam first. So kaki ayam already used up 3 atoms. Just like this one, 1, 2, 3. And you got 2 more left. So before directly attached to the parent chain, you got 2 more carbon. So this is the first carbon, this is the second carbon, and enough for 5 carbon atoms. Now this one will attach directly to the parent. So this is how isopentyl looks like when you draw it in skeletal structure. Next one, we got another substituents with 5 carbon atoms, which is neopentyl. So neopentyl is the drawing where you got C, 1 carbon atom in the middle, attached to the next CH3 with 3 of them, and one of it is CH2 that is directly attached to the parent chain, just like this structure. If you want to draw it in the skeletal structure, you can draw it parent chain attached to 1 carbon CH2 and then attached to C with CH3 around it, 3 of them. So this is how neopentyl looks like in the skeletal structure. Next one, we go to 6 number of carbon atoms where I got my structure, which is benzyl and phenyl. So let's go to benzyl first. Benzyl, which means that you got the benzene ring, but before directly attached to the parent chain, you got CH2 in the middle of them. So that is how you want to draw the structure for benzyl. However, for the next structure, when your benzene ring directly attached to the parent chain, this benzene ring that I highlight here will be your substituents. So the name of it will be phenyl. And this one only applicable when the parent chain, for this case, has more than 6 carbon atoms. For example, you got heptane, octane, or decane. Next example, we go to these structures of another substituents that can be attached to the parent chain. For example, we got this atom, fluorine atom, when it's attached to the parent chain. So all of these are going to attach to the parent chain. Their names will be changed as well as substituents, which is F will be fluoro, Cl will be chloro, Br will be bromo, I will be iodo, OH will be hydroxy. Please be careful with this one because it is without L. It is not a functional group because this structure is as substituent. And the next one we got NO2 nitro, and we got last one NH2 as amino. So these all are example of substituent that can attach to the parent chain. So that's all for this video. I just want to introduce to you how to identify common substituents as a groups or as a single atom in the structures of alkene. For the next video, we are going to learn how to give the name based on some rules. That's all for now. I'll see you in the next one. Thanks for watching. Bye.